Right now, you're moving faster than most airplanes, and you don't feel a thing. No vibration, no rushing wind, no sense that you're racing through space. That's because the ground beneath your feet has been rotating every second of your life. It was spinning before the first humans appeared, before the dinosaurs, before even the earliest forms of complex life. For billions of years, Earth has quietly turned without ever missing a beat. But what if that changed? What if our planet stopped spinning? Not slowly over millions of years, not by gradually easing to a halt. Imagine the impossible. Earth suddenly loses its rotation. What happens next? Today, we're following that chain of events, step by step, to see how one change could transform the entire planet. So first, why is Earth spinning in the first place? To answer that, we have to travel back about 4.5 billion years. Back before there were planets, back before there was even a solar system, there was only a gigantic cloud of gas and dust floating through space. Over time, gravity pulled that cloud inward. As it collapsed, it began to rotate faster and faster. You've probably seen something similar before. When a figure skater pulls their arms close to their body, they spin faster. The same basic physics applies here. As the cloud became smaller, its rotation sped up. Eventually, the young sun formed at the center. The remaining material flattened into a spinning disk. Inside that disk, countless collisions slowly built the planets. Earth inherited that original spin. It didn't have to be started later. It was born rotating. And in space, something that's spinning tends to keep spinning, unless another force gradually takes energy away. As it turns out, that force exists, and every day it's doing exactly that. The slow brake on Earth's rotation is the moon. Its gravity constantly pulls on Earth's oceans. That pull creates tidal bulges in the water, but Earth rotates slightly faster than the moon travels around us. So those bulges are carried a little ahead of the moon. The moon's gravity then tugs backward on those misplaced bulges. It's an incredibly tiny braking force, but it never stops. Bit by bit, Earth's rotation loses energy. That energy isn't destroyed. Instead, it's transferred to the moon. As a result, the moon slowly drifts farther away from Earth. The change is tiny. Earth's day becomes longer by only about 2 milliseconds every 100 years. That's far too small for us to notice. But over billions of years, even tiny changes can become enormous. And that raises an extraordinary question. If Earth's rotation kept slowing, what would our world eventually become? Now imagine that Earth is no longer rotating relative to the sun day. One side of the planet would face the sun all the time. The other side would never see daylight again. If that sounds familiar, it's because we've already seen something similar. The moon always shows the same face to Earth because it's tidally locked to us. Earth is not expected to naturally become tidally locked to the sun before the sun itself changes dramatically. But imagining a non-rotating Earth helps us understand what such a world could be like. Almost immediately, the planet would begin to divide into two extreme environments. On the day side, the sun would never set. There would be no evening, no night, no chance for the surface to cool. Heat would build day after day. Temperatures would climb far beyond those recorded in Earth's hottest deserts. Rivers and lakes would gradually disappear. The ground would bake beneath constant sunlight. On the opposite side, darkness would never end. Without sunlight, temperatures would continue to fall. The air would become brutally cold. Moisture would freeze out of the atmosphere. Ice would spread across the landscape beneath a sky filled only with stars. Between those two extremes lies the only region that might remain relatively habitable. A narrow band circling the planet, the Terminator line, a permanent twilight where the blazing day meets the frozen night. But temperature is only part of the story. Earth's rotation doesn't just determine day and night. It also helps shape the entire climate system. As our planet spins, moving air and water are deflected by what's known as the Coriolis effect. That effect helps organize the trade winds. It influences powerful ocean currents. It also gives hurricanes their familiar rotating structure. Without Earth's rotation, the Coriolis effect disappears. Air would still move as warm air rises and cold air sinks. But the organized circulation patterns that help distribute heat around the globe would no longer exist in the same way. The climate would become completely different, much harsher, and far less stable than the one that has supported life for billions of years. The surprises don't end with the weather. Earth itself would begin to change shape. Most people picture our planet as a perfect sphere. It isn't. Because Earth rotates, the equator bulges outward slightly. That means the planet is a little wider around the equator than it is from pole to pole. If Earth's rotation stopped, that outward effect would gradually disappear. Gravity would begin pulling the equatorial bulge back toward the center. Over immense periods of time, Earth would slowly become more spherical. But the crust wouldn't adjust quietly. It would crack, shift, and settle. The stresses created by that reshaping could trigger earthquakes on a scale far beyond anything in recorded human history. And as the planet changed shape, the oceans would change with it. Today, much of Earth's seawater is concentrated around the equator because of that slight bulge. As the bulge slowly faded, enormous amounts of water would begin migrating toward the poles. Many coastlines would eventually disappear beneath rising seas. At the same time, parts of the former ocean floor near the equator would emerge above the water. The map of Earth would slowly be redrawn. Continents would gain new coastlines. Others would lose them entirely. But there is one more system that could also be affected. One that most people never think about. Earth's magnetic field. Deep beneath our feet, molten iron constantly moves through the liquid outer core. Those motions generate Earth's magnetic field through a process known as the geodynamo. Earth's rotation helps organize those flowing currents, although the magnetic field is powered mainly by convection within the molten iron itself. Scientists think that if Earth's rotation became dramatically slower, the magnetic field could weaken or change over extremely long timescales. Exactly how much remains an active area of research. If the magnetic field weakened significantly, the solar wind would interact much more directly with Earth's upper atmosphere. Over millions of years, more atmospheric particles could escape into space. The invisible shield that has protected life for billions of years would become far less effective. Our planet would become increasingly exposed to the harsh environment of space. So let's put the entire chain together. Earth's rotation slows. The days grow longer and longer. Eventually, one side of the planet faces constant daylight, while the other remains in endless darkness. The climate changes dramatically. The familiar wind patterns that have shaped our world for billions of years are transformed. The day side becomes relentlessly hot. The night side grows unimaginably cold. Earth slowly changes shape as its equatorial bulge disappears. The crust adjusts. Earthquakes reshape the surface. The oceans gradually migrate toward the poles, flooding some regions while exposing new land in others. Deep inside the planet, changes to the flow of the outer core could eventually alter Earth's magnetic field. If that shield weakens, the solar wind gains greater access to our atmosphere over immense spans of time. Each of these changes is connected. They're not isolated disasters. They're all consequences of one fundamental change. The planet stops spinning. Fortunately, this isn't something we need to worry about. Earth's rotation is slowing by only about 2 milliseconds every 100 years. At that rate, our planet will continue spinning for an unimaginably long time. In fact, the sun will reach the end of its stable lifetime long before Earth could naturally stop rotating in this way. But this thought experiment reveals something remarkable. The simple act of Earth's rotation quietly supports almost every system we depend on. It helps shape our weather. It influences our oceans. It affects the planet's shape. And it even plays a role in maintaining the invisible magnetic shield that protects life from the harsh environment of space. It's one of the most important motions in the entire solar system. Yet because it never stops, we almost never notice it. That's the fascinating thing about nature. The systems that matter most are often the ones working silently in the background. If you enjoyed exploring the hidden mechanics of our planet, make sure you subscribe to AramisHQ EDU. And if there's another scientific mystery you'd like us to explore, Leave it in the comments. Thanks for watching, and I'll see you in the next one.